Okay, so this is part 2 of section 4-6. We're going to look at the cosecant, which is this function right here, and our secant curve, which is this function right here. And remember that these are the reciprocal functions of sine and cosine. So the strategy for graphing these functions is to graph the sine function, and then wherever sine is 0, you're going to have an asymptote in cosecant. And then where its maximum is, you're just doing a parabola up and a parabola down. Now this is where I see students make the most mistakes, is they think that this parabola is above the sine curve. It's not. They share this point right here. I'll zoom in on that real quick. So they share this point right here. So your parabola should be touching that point right there because they do have that point in common, sine and cosecant. And this is all the information for the cosecant and secant curves. Notice this is very similar. So we graph cosine, and then we look at where it's 0. We have an asymptote there. Where its maximum and minimums are, we have parabolas out from there. These are actually not parabolas, but they have a very similar shape. So let's go ahead and actually get into graphing these rather than just looking at their information. And what we're going to do in order to graph these to start out is we're going to look at what the sine value is at all of these angles and then look at the cosecant values. So sine of 0 is 0, pi over 6 is 1/2, root 3 over 2, 1. Then root 3 over 2, 1/2, 0. Negative 1/2, negative root 3 over 2, negative 1, negative root 3 over 2, negative 1/2, 0. So when we look at the reciprocals, so 1 over these values, well 1 over 0 is undefined. So that's going to happen there, it's going to happen here, and it's going to happen here. So there's our asymptotes. Then wherever sine is 1, this is going to be 1. And these are the points that we're going to use in order to graph. These other points are just to help us this first time. Well, the reciprocal of 1/2 is 2, 2, negative 2, negative 2. The reciprocal of 3 over 2 is just 2 root 3 over 3. And we can show the work for that. If I have 2 over root 3 and I rationalize 2 root 3 over 3. So then that'll be the same here. And we can go ahead and plot these points. So I'm going to do the sine curve in red. And so starting at 0, halfway 0, ending at 0, positive, negative. This is the sine graph. Now remember, wherever sine is 0, we have an asymptote. And then cosecant shares this point right here. They're touching, and then we're just going to go up from there. And sharing this point and down from here. That's all you have to do. You don't have to figure out these values. This is all I need to see. But I do want to see the sine graph with it. Okay. Well, you can do this for cosecant. I did it, or you can do this for secant. I did it for cosecant. But I'm going to graph an example of secant here. So I'm still going to use the same table. Well, looking at this, there's no vertical shift, there's no phase shift. The period is still 2 pi over b. So 2 pi over 1/2 is going to give me 4 pi. And here my amplitude is 3, but remember it's negative, so it's starting down first. So what I'm going to graph is negative 3 sine x over 2. So starting at 0, halfway is 0, ending at 4 pi. And because it's negative, I'm going down first and then up. Oh, you know what? this is not sine, this is cosine. We're actually doing cosine, so I'm starting down at my -3, then I'm at 0, then I'm up at +3, again, since this is -0 and -3. And there's my cosine graph, and wherever it is 0, we have an asymptote. And then from here, it's just a parabola. You want to make sure you show that they share that point, and they share this point. And if you wanted to, you could kind of finish this out here just to make your curve a little bit smoother if you want. You don't have to, but you can. You'd then have another asymptote. You could finish out those curves. And there we go. That's our last example, but on the next page you have some really helpful information. Now, this chart here is straight from your book, and I think it's a really great summary of all the different trig functions that we looked at. So this is sine, cosine, tangent, cotangent, cosecant, and secant. And then it tells you that their domain, their range, and the period. Domain, range, period. And this is really, really helpful information. So I would make sure that you know all of this information and you know the shapes of these graphs. And that brings us to the end of part 2 of 4-6.